As the question says, a car goes on a horizontal circular road of radius r, the speed increasing at a constant rate dv by dt equals alpha. The friction coefficient between the road and the tire is mu. Find the speed at which the car will skid. Now they have given us that the speed is increasing at this rate. So they have given us actually a non-uniform circular motion. So we will be having an acceleration A, which will be having a radial component as well as the tangential component. Talking about the radial component, we have obviously v square by r along the line, that is along the radius, and also we will be having the tangential acceleration as equal to dv by dt, that is the change in the magnitude is responsible due to the tangential acceleration, while this direction, that is along the center, is maintained by the radial acceleration. So we can have the resultant acceleration as under root of tangential ka square plus radial square, that is v square by r whole square plus, that is alpha square actually, where alpha is dv by dt. Proceeding ahead, how this acceleration is actually caused? If we take this as being the car which is moving on a circular road here, it is gonna move like this. There is obviously no string that is bounding this car to the center of this turn actually. So this is provided due to the necessary friction which is provided by the road on which this car is actually moving. So friction is responsible for all the forces, rather the required centripetal forces that is given to this car. So we can say that the necessary frictional force is equals to mass into acceleration. That is equals to mass under root v square by r whole square plus alpha square. But what is the frictional force? This is obviously equals to mu into normal reaction. Friends, I am not saying that the frictional force will act in this direction or that direction. There will be two components of friction, one of which will be providing the centripetal acceleration and the other being providing the tangential acceleration. We have considered the both of them here by taking n being the net normal reaction. So we can write it as mu mg equals to m under root v square by r whole square plus alpha square, giving us mu square g square equals to v to the power 4 over r square plus alpha square, giving us v to the power 4 equals to mu square g square minus alpha square into r square, giving us the velocity to be mu square g square minus alpha square into r square whole to the power 1 by 4. Now this is the speed, that is the limiting speed at which the car will actually skid. That is, if the speed is slightly more than this, then the car will skid.